A longtime runner compiled her training distances in the following chart. Fill in the missing values. Guys, everything in this column says the word total. When we were talking about division earlier, I said there's 3 parts to every division problem. There's the whole amount, there's the group size, and there's how many groups you can make. So running may be a little bit hard of a concept to fit into that, but you can at least see the whole amount. Do y'all recognize that her total number of miles is the whole amount?
Yes.
And so number of days would be how many days that she ran, and number of miles each day would be what piece of information? This would be a quantity, and this would be the distance of number of days and miles ran each day. This would be how many times she did it, I'm so sorry, and this would be how far she went. So to me, this is more of a size, and this is more of an amount, and when you multiply those two things together, you would get how far she was able to run. So when we have a missing piece of information, you can use division to find the missing piece of information. So on the very first problem, how would we work to find out that she ran a total of 408 miles and that we knew she ran 12 days? How could we figure out, 12 miles, how could we figure out how many days that took her? It is a division problem. In fact, this whole chart, you have about 4 division problems to work. So y'all help me do this division. 12 into 408. Count by 12, so we want to get close to 40, but not go over. 12, 24, 36, 40, which goes over. So we're backing down to 36. Do I start writing over my 4?
No.
No,
Go to 0.
yes. 3 times 12 was 36. Sorry about that ugly 3. Count by 12s again. We want to get close to 48.
12, 24, 36, 48.
Right on it.
Right on it.
So she ran for 34 days. She ran 12 miles each day, and her total for that 12-day period was 408 miles. Again, let's talk about the parts of a division problem. This is the whole amount. Number of days to me is like how many times or how many groups we're talking about. And this is the size of each group. 12 miles is kind of a size. I know it's kind of weird to think of distance as a size, but that's your group size, and 12 is your number of groups. All right, let's go to the next problem. This problem, remember that these 2 pieces of information are interchangeable, so we can still use division on it. We have 5 being divided into 19.5. Do I want to start writing above my 1?
No.
5 goes into 19 how many times?
2.
Try again.
1.
3.
Well, we could, if I do just 1, it's going to be 5. If I do it 2, it's going to be 10. If I do it 3, it's going to be 15. And if I do it 4, it's going to go over. So which one of those sounds the best?
3.
Yes, because remember, you want to get as close as you can, but you don't want to go over. 5 times 3 is 15. See, that's so much closer than if I had written a 5 or a 10 here. 19 take away 5 is 4. Bring down your next 5. I've already somewhat made a mistake because I usually tell y'all this. Before you even start dividing, I like you to place your decimal so you don't forget it. Or write on top of the spot where you need to be writing your decimal and you won't be able to squeeze it in later. Also, don't drop it down and work with it in the problem. Once you've placed it in the quotient, you're kind of finished dealing with your decimal. 5 goes into 45 how many times?
9.
Good. Evenly, right? It's a basic fact. So we're going to put 3.9 here. 19.5 is the full amount of miles that she ran. I'm saying it's a she. It says a long-time runner. It could be a guy too. 5 is how many days. So to me, when we're talking about a division problem, it was like 5 groups, and each group was, the size of that group was 3.9 miles. And when you multiply those two together, you would get 19.5. The next one is the same. We have 48, and we're going to use mental math this time. 48 divided by 10. When you are dividing by a power of 10, what can you do without having to do long division?
10.
You can just move your decimal. So where's the decimal in this number since we don't see it?
Behind and
At
back.
the end, this is only 1 power of 10, so we're only going to take 1 place away there at the end. We
4.
would expect it to be a smaller amount, not a bigger amount. That's one way you can check to see if you move the right direction. So 4.8. She ran for 10 days. She ran 4.8 miles each time. The last problem is different. You notice we take the full amount and we can divide by either one of these to get the other one. But on this one, do we have the full amount? No. Can we divide to get this?
No.
Think of fact families for a minute. If we divided this by this to get that, and if we divided this by this to get that, and this is in the fact family kind of business right now, what can we do with these two values to get this one?
Multiply.
Y'all are exactly right.
Teacher's post attendance.
Y'all be glad to know I already did that. Notice something interesting about this. I'm always preaching about lining up your place values. Did I line up mine?
Yes.
No, I didn't.
No.
There's the decimal in this number. The decimal's at the end of this number. For multiplication, you don't have to really worry about lining up your places because that's not how we deal with the decimal in our answer. Help me multiply. 5 times 5. Put down what?
5.
And then do what else? Thank y'all. 5 times 6.
30.
Plus 2.
32.
5 times 1.
5.
Plus 3.
8.
Good. Now what? Place saver. Why do I put that there?
Because there's
That 1 is in the. I want to right below that place. 1 times 5.
5.
1 times 6.
6.
1 times 1.
1.
We should not mess up that partial product at all. So I have 5, 7, 14, and 2. Look back at the problem. How many places are behind a decimal in this problem?
1.
So how many places should be behind the decimal in your answer? Notice I did not say just drop the decimal down into your answer. Even though that's where it would have landed, later on when we have numbers and both of them have a decimal in it, you'll mess yourself up if you start learning it to do it the wrong way. So I want you to always look at the problem in order to place your decimal. So she had a total of 247 5/10 miles on the week that she ran 15 days. Thank you, Nathan.